until the 8th second. Yeah, okay. Every time you record the FID. You record the FID. Now, tell me what has happened before I show anything. This delay incremented evolution time. Evolution is a phenomena which is time dependent and it is dynamic process with the time. What happened when you have incremented time delay? क्या होगा?
Different aspects of the proton will be observed.
Yes, they will evolve on XY plane, and you would, every time when you would detect them, they would be in a different position depending on the evolution time. So this is the NMR, this is the two-dimensional NMR spectrum, which we will revisit tomorrow. We will start all over again. I just want to give you an idea. The two-dimensional NMR spectroscopy was largely introduced for solving the problem of interpretation, and it is not so different from the one-dimensional NMR spectroscopy. It has only one difference, and that is the introduction of an evolution time. And remember, when I say evolution time, that primarily means incremented time delay. This means an incremented time delay, and because of that, a new technique was developed which is called two-dimensional NMR spectrum. This was the beginning of the dimensionality in NMR spectroscopy. Now we have three-dimensional NMR spectrum, we have a four-dimensional NMR spectrum. In our instrument, we have been recording three-dimensional NMR spectrum. Which, Dr. Athiya, which NMR we are recording right now?
Three-dimensional.
HMQC, NOSI.
Three-dimensional NOSI 15 and resolved.
And?
15 and resolved NOSI, and 13C aliphatic resolved NOSI.
So, the dimensionality is actually adding into the interpretation of the result. Okay? Don't worry about that. We will revisit it because this is a technique which will require a great deal of understanding of the phenomena. If you have any question regarding what we have discussed today, please feel free to ask. From anywhere, any university connected right now? Karachi University. Any question here in the audience?
You interpret the emulation, what we mean from the emulation in this case?
Okay, I think we'll keep this question for tomorrow because I think this we will discuss. Yes, Ramzan? Vanity vipers, because it is on Y. When you give a pulse from the same side, it's not affected. Where it will go? Right hand thumb rule.
You never mentioned the anti-X or Y in the last series of
Yeah, because I wanted to tell you that the only thing which you need to do is to just separate it also. But if you want to record a negative signal of the full of the uncoupled C13, you can do also. You have different options available, but as I said, that the one-dimensional NMR spectrum, you generally separate the big peak of the isolated C13 from the satellite doublet. Okay.
So what effect we will see when we are going from 300 megahertz instrument to 600 megahertz instrument when we are performing polarization
You see, you would have a multiple of sensitivity enhancement. when you would have a large magnet, the population will increase. And when population will increase in proton, the polarization transfer would be more effective, because that is the proton's polarization which you are using for the carbon-13. Okay? When we'll come to the soft pulses, we'll tell you how this soft pulses are applied. There are hard pulses, and there are pulses in a fixed duration of a particular frequency. Soft pulses experiments are generally used when you go into NOE and other experiments, right? Anything else? Inadequate? Happy? Polarization transfer? Happy also. Good, I am so happy. I don't think you would understand that. is a process which we will explain when we go to the NOE. We'll tell you that the single quantum transfer, the single quantum transfer when you switch the spin of 1, and double quantum transfer when you have a spin of 2. In this particular case, you also have two of the spins transfer, and that eventually lead to inadequate experiment, but it has no bearing on the particular type of experiment. It is a process through which you generate an inadequate experiment. Okay?
So I have a question regarding this inadequate. When we add the polarization transfer to increase the satellite peak intensity, so sir, we can do the polarization transfer to enhance the signal, but can we do it for increase the diamagnetic ratio, because still there is a problem, the probability of finding the two adjacent C13 in case of when we have two C13 molecules. So it's 1 in 10,000. So can we overcome that?
Yeah, always remember that gyromagnetic ratio or magnetic gyric ratio cannot be enhanced, you cannot change it, it is a constant, right? What you are doing by polarization transfer in this particular case is very simple, that you make them sensitive. And when you make them sensitive, you are starting with a sensitive one also. Therefore, overall spectrum at the end of the day would be relatively more enhanced and more sensitive. So polarization transfer is a technique which you use to begin with the more sensitive carbon-13. And it is added into now, inept is actually added in almost everything. Almost everything, and as we will proceed further, we will see that inept or polarization become almost integral part of almost everything now.
inadequate में एक जो बड़ी single C13 can we play with that? I mean, उसकी वजह से जिस तरह NOE में प्रोटॉन के लिए हम करते हैं, एक प्रोटॉन को मैनिपुलेट करते हैं दूसरा,
You cannot do that, because the chemical shift of satellite peak and the C13 is exactly identical. See, remember what is the chemical shift of a doublet? It is in the center of the two. And therefore, the chemical shift, you cannot separate by double resonance. There is no difference in the frequency of a doublet and isolated peak. There is absolutely no difference. Chemical shift exactly identical. But if you have a coupling because of anything else, for instance, if I tell you that this particular this isolated C13 is also a doublet because of CH, proton coupling, then you can eliminate proton coupling by using a decoupling experiment. So you decouple, so whole experiment is decouple. The whole experiment of inadequate is carried out under a decoupled condition. Under a decoupled condition, otherwise you get much more complicated singles. This situation is already very complicated. Yes, Maria?
Why we say the coupling is scalar? Because we have magnetization vector having particular thing, either the proton or the carbon or the carbon carbon or the proton proton. Why is it that they are scalar?
You see, the proton carbon are coupled to each other regardless of the orientation of proton on carbon. They would always be coupled. Huh? Regardless of this orientation, whether, for instance, CH2, this CH2, two protons on carbon can be an olefinic exocyclic proton, or can be an sp3 hybridized, two protons on sp3 hybridized carbon. The coupling with the proton and carbon will always be same, because the carbon would see this proton alpha alpha, beta beta, alpha beta, right? Therefore they are scalar, because it doesn't matter where they are oriented. The vector coupling is only when you have a C13, for instance, you have a proton or another proton, or C13 and a proton oriented like this. The distance between them is close, and they have a proper orientation of the magnetic vector. Therefore, they are affecting each other. Imagine you have two magnets. अब दो permanent magnet आपके पास हों. If you have two magnets, this is north-south and this is north-south also, it will make hell lot of a difference if you convert it like this. है ना? So the orientation of magnetism would affect them, would affect each other. Hell lot of a difference if you bring it like this, and if it's south-south, it will attract, and if it's north-south, it will repel. So the orientation of magnetic field vector would make much of a difference when there is a vector coupling. But when carbon is connected to a proton, they are connected to each other. They just see them as a. आपको ये magnetism का समझ में आया? But it's a very interesting experiment. You just bring two permanent magnet and you play with them. You just change the orientation, you see how they affect each other. Very simple. They attract, they repel. You can reinforce the magnetic field by bringing them together in a proper orientation. You can cancel the magnetization field by just reorienting them also, because magnetism is a vector quantity. So when you have proton and proton in space coupled to each other, they are like two magnets, either cancelling or reinforcing or whatever. Okay? Anything else? Thank you. Thank you very much.
अटेंडेंस तो बाहर होती है, अटेंडेंस बाहर होती है, जान नहीं हाँ अच्छा है, इंशाल्लाह वो भी देंगे. हाँ वो क्या रही है
Yes.